Oh, oh, check it out.
This FRQ says, let f be a twice differentiable function defined on the interval from -1.2 to 3.2 with f of 1 equals 2. The graph of f prime is given over here, and it says that f prime crosses the x-axis at -1 and 3, has a horizontal tangent line at 2. It also says let g be the function given by g of x equals e to the f of x. Write an equation for the line tangent to the graph of g at x equals 1. So anytime we need to write an equation of the tangent line, we need point and slope. To find slope, we're going to take the derivative of g. G is the function e to the f of x. The derivative of e to the anything is just itself. Because the exponent isn't just x, we're going to chain rule. So we're going to times by f prime. So here's our expression for slope. And it says that we want the equation of the tangent line when x is 1. So let's go ahead and plug in 1. F of 1 is given. F of 1 is 2, so we'll plug in 2. And f prime of 1 is given on the graph. So we have our slope. Now we just need the point. So we'll plug in 1 into the original function. To write the equation of the tangent line, we'll use point-slope form. And here's your equation of the tangent line of g at 1. For part B, it says, for the interval from -1.2 to 3.2, find all values of x at which g has a local maximum. Justify your answer. So to find any local mins or maxes, we want to look at the derivative. And we found that right here in part A. For g to have a local maximum, we want to check where g prime changes from positive to negative. So let's actually look at this function right here, regardless of any number that gets plugged in for x. So you could plug in a negative, you could plug in 0, or a positive. It's just going to affect the exponent, but e to the any power will always be positive. So since this part of g prime will always be positive, that means that f prime will affect whether the entire expression is positive or negative. So I wrote that out here. So we want to look to see where f prime is positive and negative. F prime changes from positive to negative at -1. At 3, f prime changes from negative to positive. We're going to focus right here at -1 because this is where f prime changes from positive to negative. Since f prime changes from positive to negative at -1, that makes g have a local maximum at that value. Part C says the second derivative of g is given as e to the f of x times the quantity f prime squared plus f double prime. It's asking, is g double prime of -1, positive, negative, or 0? Justify your answer. For the same reasoning from part B, this part of the problem is going to be positive. We also know that f prime of -1 is 0. So basically, we need to look to see what the value of f double prime of -1 is. Given the graph of f prime, we can look at the graph at x equals -1, and we can see that at x equals -1, f prime is decreasing, which indicates that the second derivative would be negative. So to recap, we know that this term right here is positive. We know that f prime of -1 is 0. And then we have f double prime of -1 is going to be negative. Therefore, we can conclude that the entire second derivative of g at -1 will also be negative. Part D says find the average rate of change of g prime, the derivative of g over the interval from 1 to 3.
To all the ladies in the place with style and grace.
So average rate of change for g prime is going to be g prime of 3 minus g prime of 1 all over 3 minus 1. And again, we found g prime in part B, so we're going to use that same expression. For f prime of 3 and f prime of 1, we'll look at the graph. So f prime of 3 is 0 and f prime of 1 is -4. F of 1 is 2. So you just get 2e squared.